rest of the term. The plan is to give a lecture today. Hopefully Tuesday, I can return your quiz, but some of the TAs are still marking your quiz. I'm hoping they get it done over the weekend. If they don't get it done over the weekend, they may not come back on Tuesday, so we might have to do this on Wednesday instead. If we do it on Wednesday, there'll be no Tuesday lecture, but I'll let you know via OnQ or a email. Sorry, just give me a second here. All right, and then whatever day I don't hand the test back on, there will be no lecture on that other day, because we're already done everything that's in the syllabus of the course. Next Friday is Good Friday, so there's no lecture next Friday anyway. All right, so the topic of today's lecture is design patterns. So someone, are you here? Yes, someone is here. Someone asked me a question about assignment 5. It was a really good question. So they came up to me and said, when you're using one of the text justifiers, you're making this object, but there's nothing in the object, right? So you're making a left text justifier and a right text justifier and a center text justifier. But it seems like there's no point to these objects because the objects don't have any state, right? So let's just quickly review what those classes look like in Eclipse. Right, so there's the text justifier interface, and then you were asked to implement some classes like flush right justifier that implements the interface. And then for the code that you're given, if you look at it, there's no fields, right? So these objects don't store any information, which means they don't really need to be objects, right? Because that's the whole point of objects, right? And the point of having objects is that you can have different instances with different states, right? Here, there's no state, so you don't need more than one object. And that's the same is true for the left justifier and the center justifier. How do I go back to my, oh, here we go. Right, okay, so whenever you want to justify some text, someone's got to make one of these objects, so they have to call new, right? Then they can call justify. Doesn't make sense to make these objects, so the question is there a way I can not make these objects? Right, you might think that it's not a big deal to make the objects, right? All you have to do is call new in a constructor, but that still takes up time, right? So it takes up some small amount of time to make the object and allocate the memory for it. It takes up some memory, right? And it's just not needed. So we want to find a way to get rid of this making of these objects. So we have one solution in the course already, right? We know that if you have a static method, you don't need an object to call the static method. So why don't we make justify static? So let's try it, see what happens. So we go into the interface, boop, boop, right? So there's our interface, there's our justify method, right? And we say, well, why don't we make this static and see what the compiler says about that? Because I haven't told you if an interface can have a static method, right? So what happens when we do that? All right, so we put in the keyword static. The compiler complains. It says this method requires a body instead of a semicolon. So that's something new. So an interface is allowed to have a static method, but if it has a static method, it has to have an implementation, right? And so I now have the problem of I have no idea how to implement justify because I'm inside the interface, right? I don't know what kind of justifier this is. So we can sort of fake our way out of the problem. Right? I have to do something, so I can either do nothing, but this says it returns a string. So I have to return something, or I have to do something like throw new runtime, or some other exception. Right? If I throw an exception to indicate that this method isn't implemented, the compiler is also willing to accept that. Right? So the compiler's happy now until you go down to the other justify method. The other justify method is a default method, and it calls the method we just implemented, right? But the method we implemented is static, right? And here we're using an object reference to call the method, right? We're using this. Now remember, this is just a reference to the object that was used to call justify, right? But I can't call the. Notice here that the compiler is saying this particular static method in the interface has to be called using the name of the interface. Right? So remember I told you that you're supposed to call static methods using the name of the class that it's defined in. Right? I also told you that if you have an object, you can also use the object to call the static method. Right? But that's not true if your static method is in an interface. Right? If you're in an interface, you have to use the name of the interface to call the static method. So now we have to change this. Text justifier. Okay, so now the compiler is happy with our interface. It's going to be unhappy with our classes that implement the interface. Right? So remember the classes that implemented the interface, right, override the justify method. Right? So we have our override tag here. Right? When you put in the @override tag, the compiler checks, is this method actually overriding, in this case, a method from the interface. Right? And it's not, because our method in the interface is static, and this one's not. Right? So this complains the method justify must override or implement a supertype method. And you say, fine, it's static, so why don't I make this static here and try to make the compiler happy? Right? Compiler's still not happy. It now says, oh, it says the same thing. The method justify must override or implement a superclass method. Right? And you say, well, that's weird. Right? That looks exactly the same as that. Right? Public static string justify string int. Right? Public static string justify string int. Right? And so that looks confusing. If you comment out the override tag, the error goes away. And you say, well, that's strange. But the compiler is at least happy. So let's see what happens when we do this. Right? We go down to our main method. Here we're calling justify using our variable j. Right? Hover over the error, and again it says this static method of the interface can only be accessed as using the interface name. You say, well, that's inconvenient, right? Because I know what's going to happen if I type this in. If I type in, well, I'm pretty sure I know what's going to happen if I type this in. Right? Text justifier, did I spell that right? What is it? Text justifier, like that. Okay, so the compiler's happy now with that line, but I'm pretty sure I know what's going to happen if I call that method, right? The version of justify in the text justifier throws an exception. So let me just comment out this stuff up here for the time being. All right, so let's see what happens when I run this. And I get the exception, right? It throws that runtime exception that I had right here. Right? And so that line right there now indicates that there's a second problem, right? So on that line there, my justifier is declared, its declared type is the interface type. Right? If I want to call the justify method using the variable j, right, I have to use the declared type to call the method, right, because it's a static method. Right? What if I try this? So flush right justifier. And so, oh, the compiler's happy with that now. All right, so let's try that. I'm just going to ignore this from now on. Okay, so that seems to work, right? So there's my original string, right? This is the string justified to 40 spaces on the right. Right? So that seems to work, so that's great. Now what about this method up here? Right? So this method up here takes in a text justifier a reference. Right? So it should be able to take in any class that implements the text justifier interface. Right? But notice what the problem is. Right? It's taking in an object, and I can't call justify using an object reference because the declared type of the object is text justifier. That's the name of the interface whose static method I want to call. So I have to use the name of the interface in this case. Right? And now whenever I call this method here, that's going to throw an exception. Right? And this is all because we changed everything to static. Right? So static methods don't behave the way you want them to in inheritance or when you implement an interface. So you can put a static method in as of Java 8. Right? So you can put it into an interface. If you put it into the interface, it has to have an implementation. Notice that the static method in this case doesn't solve our problem. Right? If you use a static method, right, like we did in that method I just showed you, right, you can see that static methods are never dynamically dispatched. Right? In other words, back here, right, I can't use the runtime type of J to call the right version of justify. Right? I have to use the name of the interface. Right? So I can't, there's no way for me to tell which class this came, well, there's no easy way for me to tell which class this came from. Right? So static methods don't behave the way you want them to when you try to use polymorphism. Right? They are never dynamically dispatched. Right? The runtime type of the variable you use doesn't determine which version of the static method you get. It's the declared type that determines which version of the method that you get. That's not what I want in this case. Right? There's a second problem. So when I left that override tag in the class, the compiler complained. It said, this isn't overriding a method from the interface. And the compiler was right. Right? You can't override a static method. You can't override it from a superclass. You can't override it from an interface. Right? The reason you can't override it is because it doesn't behave polymorphically anyway. Right? The runtime type of the object never determines which version of the static method you get. So it doesn't make sense to be able to override it. Right? If a class attempts to override a static method, then what ends up happening is the class defines its own version of the static method. Right? So in other words, it hides the version that it inherits from the in this case from the interface or from its superclass. Right? But the method never behaves polymorphically. So this doesn't solve our problem. Right? I can't write polymorphic code like this, right, where I can pass in any one of my justifiers and have it do the right thing. Okay. Whoops, sorry. Want to justify some text. I bet you I made this mistake elsewhere too. All right. So making a static method doesn't work, but we know that if you have a static field in a class, right, that field belongs to the class, and there's only ever one copy of that field. So that sounds like that might work, right? Because there's the whole problem is I want there to only be one object for each type of justifier. Why don't I make a static field to represent that one object? So let's try that. So I have to undo everything I just did, so give me a second here while I undo the changes here. Save that, change this to this, that, go back here, change this to J, change that to J, and take off the static, and take off the, okay. So let's make a static field. So inside my justifier class, I'm going to make a static field. So I'm going to make it public. It's going to be static. I'm going to make it final so that we can't change it. And I want an instance of my justifier. So I'm going to make a flush right justifier object. Oops. Public and we'll call it instance equals new. Yeesh. Flush right. Just like that. Right. Okay, so I just made a variable called instance inside my text, inside my flush right justifier class. Right. It's just an instance of one of these of this class. Right. It's final and it's static. Right. So there's only one, and I can never reassign it to a different object. Right. Compiler's pretty happy with that, so there's no complaints. Right. Now down here, instead of making a new justifier every time, oops, sorry, I can just write text justifier, j equals flush right instance. Like that, right? So now I don't have to make a new object every time. I just use the one instance that was declared by the class. Right? And every, oh, exception, oh wait, where do we go? 29. Public. Oh, right. Sorry, I have to undo that. There we go. Run that. Okay, and everything's fine. Right? So it looks like that's one possible solution to, where'd my mouse go? Uh-oh. Not that, sorry. Does this work? Okay. Right, so it looks like that solves our problem of of unnecessarily creating objects, right? We can make an object, store it in the class in a static field, and now anybody who wants to use that one object just asks for that object from the class. Right? So it turns out this is very common in the standard library, right? All of these classes here are examples of classes that declare static variables for the user to access. Right? So in color is the class that's used by, well, it's the class in this package called AWT that's used to represent red, green, blue colors. Right? If you look at its fields, there's a whole bunch of public, static, final fields that correspond to a small-ish number of standard colors. Right? So the color class in Java is immutable. So when you make a color, you can't change it. So it doesn't make sense to keep on making a blue object every time. You might as well just make it once and give people access to it. Right? Of course, you can. It does provide you with a constructor to make different colors. Right? But if you want one of the standard ones, just use one of the objects it already made for you. Right? The Boolean class, so that's the wrapper class for the little b Boolean type. Right? There's only two Boolean values, true and false. So not surprisingly, there's a static final constant, that corresponds to false, and there's another one that corresponds to true. Right? It doesn't make sense to have to use the constructor to make true or false. Right? Collections. So this is the class that provides a bunch of utility methods for operating on sets and lists. Right? It provides an empty list, an empty map, and an empty set. Right? These are immutable. So if you really want an empty list, you can just write collections.emptylist, right, and use that. Right? If you really want an empty map, you can use collections.emptymap and use that. Right? You might wonder, why do you want one of these things if you can't add anything to it? Right? And so the answer is it's useful for returning from methods that have to return a list. Right? So if the list, instead of returning null to indicate an error, you can return the empty list instead. What else is there? String. So the string class, well, we all know what the string class is. Right? It provides a static final field that's a comparator object. Right? And so that comparator object knows how to compare strings, ignoring their case. Right? So remember, string implements compare_to. Its compare_to method by default compares strings considering the case. Right? But it's pretty common that you don't care about the case of the strings. So the string class makes a comparator object for you that can compare strings ignoring the case. Right? So you don't have to make your own comparator object. Right? And there's lots and lots and lots of other examples of these static objects in the standard library. Right? We're still not quite done. We're almost done, though. Right? So it's still possible to make a new object. Right? So we'll go back to our class. No, that's not right. Go back to our class. Come on. Okay, so there's our class. Right? We've got no constructors in the class. Right? So remember what happens if you make a class that has no constructors? Java makes one for you. Right? So in other words, the compiler silently inserts public flush right justifier. Bloop. Like that. Not quite like that. So if you don't make your own, if you don't declare a constructor in the class, that's the one you get for free, right? You might wonder, why do you get one of these, right? You actually know the, well, I've told you what the answer is, or I've told you enough to figure out what the answer is. So the reason you get one of these is because this thing here, right, is a subclass of object, right? In order to make one of these flush right justifiers, you have to make the big O object that is part of one of these flush right justifiers, right? So how do you make the big O object part, right? You need to call the superclass constructor on the first line of every constructor, right? So if Java didn't insert this constructor for you, there would be no way to create the object part of this object, right? So that's why Java silently inserts this one for you. All right, so that's not, so if I make it public, anybody can use this, right? So down here, we can do that instead, right? So this still works, right? I can still make that object there, right? If I get rid of the constructor, right, so it's gone now. I can still make one of those because the compiler makes up a constructor for me, right? And so if I really want people to not be able to make one of these, right, the solution is the same as in a utility class. You just make the constructor private, right? Now that line runs just fine because I can call the private constructor from inside the class, right? This line runs because main is inside the class. But if you were outside of the class and you tried to make a new object, it wouldn't work because it would say the constructor is private, right? So that now solves our problem, right? We've got a public static final field that holds the one object, right? We've got a private constructor, so that stops anybody else from making an object, right? And we've just discovered a design pattern. So this is called the Singleton design pattern. So a software design pattern is, this is quoting directly from Wikipedia, right? A general reusable solution to a commonly occurring problem within a given context in software design, right? And so problems like, I only want one of these objects, occur with some regularity across many different programming problems, right? Patterns are supposed to be solutions that solve these commonly reoccurring patterns, right? If you talk to the people who hire you after you graduate, right? So in other words, if you talk to the hiring people at companies or the people who interview you when you go to interview for a job at a company, a lot of them will complain that students coming out of undergrad have never heard of software design patterns. And it's true. It's often not taught in your undergrad education, right? One of the reasons it's not taught is because it's hard to recognize patterns if you haven't written lots of software, right? And you don't really write a ton of software in undergrad until you've completed third or fourth year, right? And so it's kind of hard to teach these things because you don't really appreciate them, right? Say, well, yeah, okay, that's neat. It does what it's, you know, it just did what you told me it's going to do. But you don't have any real appreciation for it until you've started writing a whole bunch of software and resolve these problems on your own, right? So if you're planning on doing, pursuing a software development career, it's worth your time researching this topic on your own, right? The pattern that we just rediscovered was the Singleton pattern. So the Singleton pattern restricts the instantiation of a class to a single instance, right? There's exactly one object of our, for each justifier. Right? So that's its main purpose, right? Ensure that there's exactly one instance of a class, right? Now, if there's only one instance, people are going to need access to it. So it also needs to ensure that people can access the instance. Our field is public, so anybody can get to it, right? There are some applications where you want to control when that object is created, right? So there's extensions to this, well, there's variations of this pattern where you can control when the object is actually created, right? In our implementation, right, the object is always created when the flush right justifier class gets loaded into memory, right? So in other words, when you first use it, that object gets created. All right, so there are variations on this. So one variation is, instead of having a public field, you make it private, right? And then you provide a public static method to access the field, the instance, right? And in Java, the preferred way of doing it is to use an enumeration. Right? So remember what enumerations are in Java, right? So if you have a small number of constant objects, it's often, sorry, if you have a small number of constant objects that you know ahead of time, right, then you're encouraged to use an enumeration, right? So can I turn this thing into an enumeration? The answer is yes, you can do it easily, right? So to convert this into an enumeration, you just change class to enum, right? Now remember how enumerations work, right? You just list all of the constants in a comma-separated list. So I'm just going to make an instance called instance, right? Get rid of this, because I don't need it anymore, right? Get rid of, yes, get rid of this. Sorry, get rid of the constructor now, sorry. Oh no, so we just leave it, we can just leave it like this. Right. Actually, I guess if it's an enum, I don't need this at all, so we can get rid of that completely, right? And there you go, right? So enumerations in Java, the language guarantees that there's exactly one of these, right? And so this also gives you exactly one flush right justifier object, right? Without having to make a public static final field and so on and so on and so forth, right? You get all of this machinery for free. All right, so Singleton ensures there's exactly one instance per class, right? There's occasionally, sometimes, you want to be able to have multiple instances of a class, right? But where each instance has a unique state, right? And now I want to ensure that there's exactly one object per unique state, right? So for example, the integer values, so 1, 2, 3, 4, 5, 6, 7, 8, up to whatever, right? There's only the integer class, sorry, in Java, right, is immutable, right? So remember the integer class, it's the wrapper class for ints, right? It doesn't really make sense to make a different integer object for every int value, right? You can, so you can write new integer, but it doesn't make any sense, right? Because the class is immutable, I can't change the state of an integer anyway. And so there's an example of when you might only want one instance for every unique state, right? This works easiest if the objects are immutable, right? If the objects are immutable, then it's hard to ensure that there's only one object of each, one object corresponding to each state. Actually, I guess it's impossible if it's mutable. All right, so I want multiple instances. I need somewhere to store them, right? So I need some sort of data structure. So I have to consider an array or a list, maybe a set, right? I want to ensure there's exactly one instance per unique state, right? So that per unique state sort of suggests that you can use the state as a key in a map. Right? So in other words, I can look up an object by asking, using its state, right? To get the object, right, I can store the objects in the map as the values. Right? So your keys are your states, and your values are the object that corresponds to that state. Right? I only want one of these maps, right? So I don't need multiple maps containing all of the different instances. One will do. And so again, a static field will suffice for our purposes. So let's try this. Okay, so my integer. So the integer class in Java, remember, is the wrapper class for ints, right? I'm going to produce a different implementation of the integer class, right? The integer class doesn't do it this way. It doesn't do it the way I'm showing you, but they could have, right? But they didn't do it this way. So every int or every my integer object simply wraps an int value, right? So we have a constructor here, right, that takes in an int value, right, sets this value to the value. It's private because I don't want anybody making my integer objects, right? I want there to only be one per each unique state, right? If I let other people make these objects, then they can make multiple objects corresponding to each int value. So I have to make this private, right? Now, I need a somewhere to store the private somewhere to store the objects corresponding to each unique state, right? So I'm going to make a private map, a private static map. I'm going to make it final, so I can't accidentally change or reassign the map. So my keys are going to be the state, right? So the state is just an int. So there's an integer, right? The values are going to be the my integer objects that correspond to a given state, right? So my integer, right? And so these are going to be my instances. It's new. I'm going to use a hash map. Right? Because if I'm going to be looking up the objects in my map, I want it to be fast, right? So I'm going to use a hash map in this case. All right, now how do users of the class actually get an instance, right? So how do they get a my integer object? So I have to provide a method to do that. So public static, I need to return a my integer object, value of. Okay, so in the integer class, that's the method that's called when you convert an int value to a big integer value automatically, right? So when the compiler auto boxes an int and converts it to an integer, it just calls value of, right? So our value of is going to look as follows, right? I want to return the my integer object whose value is that. So all I'm going to do is I'm going to look up that value in the map. So my integer I equals instances get value, right? So get that object from the map, right? Now get returns null if the object isn't there, right? So if our map doesn't have an instance equal, say, the integer 5, right? I will be null, right? It's not null if it does have one. So if I is not null, I can just return I. Right? So there's my integer object that corresponds to the value 5, for example. Right? All right, so on this line here, I is null. So that indicates that there is no my integer object corresponding to the value 5. Right? So make one. Right? I can call the constructor because, even though it's private, because I'm inside the class. Right? Now take the value you just made and stick it back in the map. Right? So that the next time someone tries to get the value 5, you can get it out of the map. And now return the newly created my integer object. So what we just did there, right? So we've just rediscovered what's called the multi-tin design pattern. Right? So in a multi-tin, that allows for the controlled creation of multiple instances, right? One instance per unique state. Right? So this kind of makes sense for a class like integer, because there's a lot of integers, right? 2 to the 32. Right? If you have a small number of constants, right? So fixed finite number of constants that you know ahead of time, you should just use an enum. Right? But in cases where you have something like an integer or a string, right, it kind of makes sense to consider this pattern here. Do I talk about that? Yeah. All right, so that idea, so what we just did there, right? So notice here in the value of method, right, I look up, is there an object that does, is there a suitable object that I've already made, right? So I look in the map for that object. If there is, we return the object, right? So in other words, I'm storing the objects that I've previously made in the map, right? So that idea of storing objects and retrieving them when needed, instead of making new objects, right? That's related to this idea called caching, right? So a cache in computing, caches appear everywhere, right? So a cache is a hardware or software component that stores data so that future requests for that data can be served faster, right? Hardware or software. So in a modern computer, there are many, many caches, right? Your CPU probably has 3 or 4 or more caches for memory, right? Your memory controller almost certainly has a cache. Your disk controller has a cache, and so on and so on and so forth, right? Our myInteger class has a cache, right? It's got a map that stores the created instances, right? Some of the Java classes also have caches in them. So the integer class itself has a cache, right? The string class also has a cache. I'll talk about that in just a second. So if you actually look at the source code for integer, which is right here, you can just Google Java integer source code, and you'll get a link to it, right? So here's our class integer, right? It's got a bunch of stuff in it. We don't really care about that. What we care about is this, right? And so the Java language specification says the class integer, I think all of the integer, short, byte, all must store or cache some number of values, right? And so this implementation here stores all the integer values between -128 and 127, right? So in other words, for the frequently used integers, right, these are all kept in a cache somewhere. The cache is really primitive. It's just an array of integer, right? So it's an array of 256 integer values, right? If you go and look for the value of method, the other value of method, there, keep going. Here we go, right? It works exactly the way that I just showed you, except it uses the array instead of a map, right? So it checks, right? Is the value, can it be inside the cache? So this cache only keeps values between min cache and max cache. So if you're outside of that range, it returns a new integer object, right? Otherwise, it looks in the array, right? So is the integer object we're looking for, is it already in the array, right? If it's not, make that integer object and store it in the array, right? Then return the element that's at that location in the array, right? So the integer class here does exactly what I just showed you, well, in a different way for the myInteger class. Oh, sorry. The string class is funny in Java. So the string class does something called interning. And so all that means is that if you have a string literal in your program, so something in double quotes, right, then the string class ensures there's only one instance of that literal, right? So if you use the string hello somewhere in your program and you use it over and over and over again, right, the string class stores exactly one instance of that string, right? So internally, it's got somewhere it's storing all the string literals that are in your program, right? That's why equals equals seems to work when you compare string objects, right? So remember what equals equals does, right? Equals equals tests are the two objects the same object, right? Which isn't what you want to do with strings, right? If you want to test if two strings are equal, you want to know, do they have the same sequence of characters, right? The reason it seems to work, though, right, is because often when you're trying it out in a program, you're writing something like if hello equals equals hello, right? But that string hello has been cached by the string class. So there's only one instance of that string hello, right? And that's why equals equals seems to work when you try to test it in these little tiny programs, right? It only breaks when you actually make a new string object, right? And then you use equals equals, and suddenly it's no longer equals, right? And so for the string cost, that idea of caching has an unexpected side effect. But it does it in order to minimize the amount of memory that's used by strings in your program. All right, so there's a very quick and dirty introduction to design patterns. There's lots and lots and lots of these design patterns. And I encourage you to poke around and see what you can learn about them. Right? When you start to look at them, you'll quickly realize that a lot of them don't make any sense to you because you've never been in this situation where you've needed them. If you like, if any of you are interested in video games, though, or in how you might program a video game, Google game design patterns. And there you are. The first link you should get is this one. And that's a free online book somewhere. Ebook. It's free, right? I'm pretty sure it's free. PDF. There. Wait. Web? Here. The web version is free. And so this is a book that tries to teach you about programming patterns via game development, if you're interested. All right. So that's all I have for today. Have a good weekend. Tests will come back next week. Look for my announcement on OnQ as for the actual date in case they don't get marked on time.